Welcome to a new video. Today we will try to compare the newly released image of James Webb with the older image released by the Hubble. The number of stars visible in the Webb image versus the Hubble image, both in the pillars of the nebula as well as in the background. Webb is able to see stars through and behind the gas and dust clouds. In infrared light versus Hubble seeing invisible light where the vast majority of stars are obscured by the intervening gas and dust clouds. This is a key attribute of Webb's view of the universe. Webb's new view of the pillars of creation will help researchers revamp their models of star formation by identifying far more precise counts of newly formed stars. Along with the quantities of gas and dust in the region, Webb often gets called the replacement for Hubble, but it is a successor. Hubble's science pushed us to look to longer wavelengths to go beyond what Hubble has already done. This image is comparison of the Carina Nebula in visible light and infrared, both images by Hubble. In the infrared image, we can see more star-forming regions. In particular, more distant objects are more highly redshifted, and their light is pushed from the UV and optical into the near-infrared. Thus observations of these distant objects requires an infrared telescope. This is the other reason that Webb is not a replacement for Hubble. Its capabilities are not identical. Webb will primarily look at the universe in the infrared, while Hubble studies it primarily at optical and ultraviolet wavelengths. Webb also has a much bigger mirror than Hubble. This larger light collecting area means that Webb can peer farther back into time than Hubble is capable of doing. Hubble is in a very close orbit around the Earth, while Webb will be 1.5 million kilometers away at the second Lagrange point. Webb will observe primarily in the infrared and will have 4 science instruments to capture images and spectra of astronomical objects. These instruments will provide wavelength coverage from 0.6 to 28 micrometers. The infrared part of the electromagnetic spectrum goes from about 0.75 microns to a few hundred microns. This means that Webb's instruments will work primarily in the infrared range of the electromagnetic spectrum, with some capability in the visible range. The instruments on Hubble can observe a small portion of the infrared spectrum from 0.8 to 2.5 microns. But its primary capabilities are in the ultraviolet and visible parts of the spectrum from 0.1 to 0.8 microns. This is Hubble's visible and infrared views of the Monkey Head Nebula. Why are infrared observations important to astronomy? Stars and planets that are just forming lie hidden behind cocoons of dust that absorb visible light. However, infrared light emitted by these regions can penetrate this dusty shroud and reveal what is inside. At left are infrared and visible light images from the Hubble Space Telescope of the Monkey Head Nebula, a star-forming region. A jet of material from a newly forming star is visible in one of the pillars, just above and left of center in the right-hand image. Several galaxies are seen in the infrared view, much more distant than the columns of dust and gas. How far Webb can see. Because of the time it takes light to travel, the farther away an object is, the farther back in time we are looking. This illustration compares various telescopes and how far back they are able to see. Essentially, Hubble can see the equivalent of toddler galaxies and Webb telescope will be able to see baby galaxies. One reason Webb will be able to see the first galaxies is because it is an infrared telescope. The universe is expanding. When we talk about the most distant objects, Einstein's general relativity actually comes into play. It tells us that the expansion of the universe means it is the space between objects that actually stretches, causing objects to move away from each other. Furthermore, any light in that space will also stretch, shifting that light's wavelength to longer wavelengths. This can make distant objects very dim at visible wavelengths of light, because that light reaches us as infrared light.
Thanks for watching. Please consider subscribing to this channel.